I'm Travis Cuvelier.
I'm Scott.
And we're in the Cornell ECE M.Eng program. So our project was Resilient Communication Systems for the MITRE Corporation. MITRE is essentially a nonprofit lab that does work for the government and the Department of Defense. So this project is relevant to tactical airborne networks. So that's the data links and communication systems used by like fighter pilots. And so what can happen in those networks is that enemies can jam you, and what that means is essentially they can create a lot of interference intentionally to prevent you from being able to communicate. So our project is inspired by the fact that information theory sort of tells us that a good way to design communication systems is to first focus on compressing the data down that you want to send as small as possible, and then sending that compressed data as reliably as possible. Now, if you can send only a certain amount of data in a certain amount of time, the more compression you achieve, the more resilient you are to errors induced by noise. So essentially what we do is we replace typical systems to compress human voice with text-to-speech technology to achieve a much higher compression ratio than is normally achieved in these tactical radios.
So we put together a flow for this game that uses a commercially available speech recognition software called Dragon. And we take the text output of that, which turns out to be 100 bits per second, use some pretty basic repetition channel encoding, and we're able to show an improvement over existing voice codecs. So it's able to tolerate 9 dB or 8 times more noise than existing voice codecs.